The problem states that a green light is incident from the water to the air-water surface at the critical angle theta. Select the correct statement. Statement A is the entire spectrum of visible light will come out of water at an angle of 90 degree to the normal. Option B is the spectrum of visible light whose frequency is less than that of green light will come out of the air medium. Option C is the spectrum of visible light whose frequency is more than that of green light will come out of the air medium. And the final option, that is option D, says the entire spectrum of visible light will come out of the water at various angles to the normal. In order to solve this problem, first of all, we need to know a number of things. Number 1, in order to achieve total internal reflection, the ray must travel from denser medium to rarer medium, or let me correct myself, the ray must travel from optically denser medium to optically rarer medium. Suppose this is optically denser medium and this is optically rarer medium, and this is the ray of incidence and this is the angle of incidence. So in order to achieve total internal reflection, the first condition is the ray must travel from optically denser medium towards optically rarer medium. And number 2 is the angle of incidence, that is theta. This must be greater than or equal to the critical angle, that is C. If theta is greater than or equal to C, then the refracted light will either follow this path or it will be totally internally reflected, that is, there will be no refraction. From Snell's law, we already know that sin I divided by sin R is equal to mu or n. Now, if I is equal to the critical angle C, then the angle of refraction will be 90 degree, that is R is equal to 90 degree, or in other words we can say sin C divided by 1 is equal to n. But we know this n, that is the refractive index, can be written as mu of rarer medium divided by mu of the denser medium. These mu's are the absolute refractive index, that is, mu of R is the absolute refractive index of the rarer medium, whereas mu of D is the absolute refractive index of the denser medium, and the n represents the relative refractive index of these two mediums. So we can write sin C is equal to mu of R divided by mu of D. Here the rarer medium is air, whereas the denser medium is water, and we know that mu r of air is almost 1, and we represent mu d as n of water. So we can say that sin C is equal to 1 divided by n of water. But at the same time, we also know that n of water is equal to A plus B divided by lambda square, where A and B are constants and lambda represents the wavelength. We need to know one more thing, and that is the VIBGYOR. Violet, indigo, blue, green, yellow, orange and red. In this direction, the wavelengths increase, and the frequency increases in this direction, which means wavelength of red light is greater than that of orange colored light, and wavelength of green colored light is greater than that of blue light. In the same way, we can say that frequency of indigo colored light will be less than that of violet colored light. So in this direction frequency is increasing, and in this direction wavelength is increasing. So wavelength and frequency are inversely proportional to each other. When wavelength is increasing, frequency is decreasing. So frequency of yellow, orange and red colored light are less than frequency of green colored light. But we already know that frequency is inversely proportional to wavelength. So when frequency decreases, wavelength increases, and as wavelength increases, this entire part B by wavelength square, that is lambda square, decreases, and when this part decreases, this entire part also decreases, which means when frequency decreases, in water also decreases. But also note here that sin C is equal to 1 by n water. So when n water decreases, 1 by n water increases. That is, sin C increases, which means that if sin C is the critical angle for green colored light, the critical angle for these three lights will be greater than its critical angle. And we have already seen that the green light is just getting this pathway after refraction. That is, this is the critical angle of green colored light. So, in case of yellow, orange and red colored lights, this critical angle will be greater. But since all the lights are in the visible spectrum, hence all those lights are coming along with green colored light. So both G as well as YOR and VIB are following this path, and that is they are incident by angle C. Hence those lights, that is YO and R, will not undergo any kind of reflection, that is total internal reflection, or this path. Instead, they will just come out at an angle less than 90 degrees. Therefore, option B is the correct option, that says the spectrum of visible light whose frequency is less than that of green light, which means the frequency of yellow, orange and red, which are less than green, they will just come out of the air medium.